So this is the Angular Meetup. We're doing lightning talks. We're just going to get started here. Our first talk speaker is Nathan Dickson.
Okay. Whoa.
That was my bad. That was my bad.
We just entered the twilight zone. Okay. So there you go. I guess anyone, I think you have like a application that you might use Electron for? Anything that comes to mind that you would want to like deploy as a like VS Code / Atom sort of project, like or deployment?
Something that doesn't have platform dependencies.
Say that again?
An application that doesn't have a platform dependency, so it has to be like Xcode, has to run on a Mac because of various dependencies. So you have no reason to run that cross-platform.
Yeah, totally. Right. Yeah, you get a really nice cross-platformness out of it. Under the hood, it uses Node, and they smashed together with Chromium Core. So they said, hey, we like Chrome, right? And everyone writes to Chrome. And so if you have a web app that's written to Chrome and you want to release that as a native app, let's say you've got folks who won't use Google Chrome, right? Like we have some customers that like they don't want to use Google Chrome, right? You'd be like, why don't you run our web app as this local just executable, right? It just works, and then it actually runs Chrome, and so what ends up happening is you start up a Node.js instance, and you say, I want to start up Electron. Give me a browser window. And when you say give me a browser window, Electron took Node and smashed it together with Chromium Core. So they broke Semver, which is kind of odd, kind of interesting. They because of the two of those, they can't actually do Semver releases of Electron because they're combining two already previously released Semvered products. So how do you make that into another Semver? So they just said, forget it. Just use the absolute Semver version. So what you get is the ability to run a Node app with any number of browser windows on your machine, and it just works looks like a native app. It can work just like a native app, but actually they're just frameless Chromes. So there's a fun little thing someone made to kind of demonstrate called the NativeFire, and literally you just npm install NativeFire and then call it, and after you call it with like, here's the name of my app, here's the URL. So what this does is different projects out there that support Electron, right? It's a very noisy ecosystem, and it's hard to kind of figure out what's what. But some have like bubbled to the top. Like there's a packager that are very popular. And so NativeFire just said, well, I'm going to take the packager and builder, roll it all into one, and just give you one input. What's the URL you want to hit? And then, wow, we'll make a local app for you. So in fact, I did that with Bullhorn's website, and then voila, it's like you could hand it off. It's like an installable, executable. You can build it for whatever, and all it does is it just points to a website and leaves everything else alone. They stripped down Chrome without anything. It's frameless. You actually get a context menu that. This is like default, whatever they provide. But Electron allows you to work with the context menu, the system menu, right? So now you actually have to define different menu items for Windows versus Linux versus Mac, right? Because you have to match that local platform. And that's really the only real like matching the platform thing you have to do, is if you choose to define this this menu at the top to tweak that to be relevant. So that's NativeFire. And so one interesting use is if, let's say, you build an app for Chrome and someone says, well, you need to be able to support, all platforms, whatever. You could do what Slack did and say, actually, we're just going to deploy this as a local executable. If you don't want to use Chrome, like if you try to access slack.com from like IE11, they give you a nice warning that says, your browser is bad and you should feel bad. But it's cool. If you want to support a web app in places that Chrome can't go, or because of policy or whatever, voila, you've got Electron can handle that for you. And if you don't want to support every browser available, maybe this can get you by. A cool use case. So let me show off what I've done recently. I can talk about how this applies to Angular. All right, so we talked about Electron. How does Angular factor into this? So it turns out that the Electron community is mostly supporting like vanilla JavaScript or React or other real lightweight frameworks. There's really no one who's done any decent integration of Electron and Angular. And it turns out it's not like super popular. So you've got Electron Forge is a toolkit out there that I tried to use for a while. Like it's supposed to provide all the packaging for you and everything. And it really doesn't support Angular. So that was like a week of my life I can't get back. Also, there's a gajillion different Electron userland projects out there. And scouring through these, it's like, holy cow, well, what actually makes sense? What should I use? There's a lot there. You've got the packager, you've got the builder. They both do like basically the same thing. And I was like, oh, cool, I finally found this guy who put together Electron and Angular. This is great. Okay, he's got an example. He wants my money, and he's going to be able to tell me how to put them together and make it all work. Turns out this is actually a pretty poor setup. Like, he had to eject the Webpack config from Angular to make this work, and then did a lot of hacky stuff in the background. And there's like 50 commits. I'm like, holy cow, I didn't want that. I wanted like Angular CLI and Electron. Like, just let me do it. So I ended up having to roll my own a bit. So it ended up being a lot of learning up front to figure out what the step should be. But in the end, I was able to get a true Angular CLI app, right? So everything you see here within source app is the Angular CLI generated app, right? And then you've got this main process over here that's Electron. And then really the difficulty just comes into how to package it up. So I spent a lot of time just making sure that the packaging worked properly. And for that, it was a little bit of a workaround. I had to essentially build the prod version of the Angular app and then tell Electron to now wrap it up. There's some real nice out-of-the-box stuff that's supposed to allow you to do real-time development mode, file watching and everything for your Angular, for your Electron app. But when you have file watching going on in Angular and file watching in Electron, they're both very opinionated about what they're going to do. So what I ended up doing was actually making a kind of a two-step approach. So I left, with the Angular CLI being left as it is, I can do an ngServe. And so that allows me to, if I just want to run the web app, I can go to the local web app, run it, test it all real fast, and then when I'm ready, I can go ahead and package it up as it's going to be packaged in the Electron app and do testing for actual files. So like in this example, I've got the Webpack running as well as I've got the real app, so I can show you guys. The app looks a little like this. So this is the Webpack CLI running. This turned out to be a great use of Electron for us. Well, it's kind of odd. We have a command line application that exists that gets used all the time to load data, and it was not feasible at this point to actually wrap that into a client server model. and it's not feasible to write that entirely as an Angular app and get rid of all the Java. So we kind of have to have this Java CLI running. And so our best bet was actually to wrap this Java CLI in an Angular Electron app, because we really wanted to reuse all of the great Electron or Angular components. So when you run the Electron app, it doesn't matter what you select, we come back with some fake data that just helps stuff work. So I wrote the services to where they'll just return fake data that way. And then if you run the actual app, now you'll see I can go to load a file. When I select a file, it's going to actually read that file. It's going to tell me what's in the file. It's going to allow me to do stuff that I need to load the data, how it's going to duplicate check all the input data and all that. And then I hit load. It's actually going to call the real CLI and report back what happened. And then what's cool is you can give like system updates. You can say in like pop-ups here in the system tray, here's what loaded, whatnot. You can stop the process if you need to. You can get real-time feedback from the files. And so it looks and feels like an Angular app like clients are used to, yet it also runs locally, which is nice. And then it solves the issue for us of we've got this command line application we're sending out. And folks internal to the company are using this command line application. And so that's like super frustrating, and no one can get over like the command line quirks in support. So hopefully rolling this out, it'll be a real simple, hey, we can package it in Electron, we can ship it in Electron, and we can also auto-update it in Electron. So they never have to even worry about being out of sync or running old stuff. So that's where we're at. Any questions?
Do you have any problem with the auto updates? I remember when I tried Electron for some prototypes, a lot of complaining about the update not working on Windows or working on Windows and working on Mac.
Oh, the update to like the Windows Store, you mean?
No, the auto update, just like when you start Visual Studio Code, it's
Oh.
going to try to update itself. And the feedback I got was that it wasn't working. Did you have any problem there?
You're talking about when you're running Electron in like debug mode, and you're auto watching the files, that sort of updates?
Oh, no. Okay. You were talking about that. I was talking about auto update of the application. Electron app.
Oh, yeah.
That's going to check periodically the server for new packages, so it updates itself.
Huh.
Like an app auto updated,
Yes.
like Visual Studio Code.
Yeah. So you're having trouble with Visual Studio Code auto updating, or your app?
Part of the gets some package.
Yeah. I don't know.
Probably not.
So this isn't released. Is this application released?
No, and it won't be released to the public. It's going to be released internally.
So you're probably wondering, like, if you've had any problems with auto update in some of the Electron apps you deploy.
Oh, no. I haven't deployed to the stores. No. Yeah. So, yeah, I haven't been there. Won't need to deploy to the Mac store or anything, which is nice. Any other questions?
All right. So can you mute your mic?
Yes.
And then Pete can take over.
All right.
Let me share my screen. Okay, so hi, and welcome to my talk on Angular Universal. Just to briefly reintroduce myself, my name is Peter Monroe. I work here at Bullhorn. I worked here for about 3 years. I'm a full stack developer, but I focus mainly on front end. I definitely like it more. When I first joined Bullhorn, we had a Cold Fusion app and an Angular JS app. Kind of started to really like Angular, like JavaScript a lot more, and then the last year and a half, we've been working on an Angular 2 app, and like I said, Angular 4 now. But and I really just fell in love with Angular. It's so easy to work with. There's documentation's great. It's really cool to build out stuff and really powerful. And and so that's kind of where this Angular Universal talk came from. I've heard a lot about Angular Universal in meetups like this, conferences, just side conversations, and then even here internally at Bullhorn, we've talked about it for some of our open source projects. So that's kind of why I wanted to just get a brief knowledge base of it. So I will preface this talk by saying I'm no expert at Angular Universal. This is really just a bare bones kind of me, how I walk through the tutorials and whatnot, and kind of just learned it. So might not be able to answer all your questions if you have any, but hopefully this is useful for you. Just first overall, basically, why Angular Universal, why server-side rendering. SEO is the main thing everyone always brings up. Google does say that their Google bot can scrape and crawl and index most dynamic websites. They say other search engines aren't as good. They're all expecting like a static HTML page. So server-side and serving that up is going to give you exactly that. So it's able to index your page or your dynamic site. Social media embedding. If you've ever seen on Facebook or Twitter, you share a link and they'll have a cool little preview of the website. Again, it's expecting a plain HTML page, so also causes issues if you're a dynamic site. And then the perceived timing, like obviously it's already rendered, so the user sees your site immediately. It's a little faster, maybe a few hundred milliseconds, but it makes a difference in just the perception of the speed of your site. Couple of downsides or things to watch out for is you can't directly manipulate or access the DOM. I read some articles about how to indirectly access it. I didn't get into much, but ng class, ngSTL, ngIf, there's plenty of other ways. But and then you have to make sure any of your libraries that might try to access the DOM as well, or anything else that could be incompatible with server-side rendering. And then the final is you need a server. It just I think it's pretty obvious with the name. So. Cool. So next, I just kind of want to dive into the code a little bit. I create a real basic app. There's basically no UI to it. It's an Angular CLI app with just some of the extra stuff added on. Here's sort of a cool diagram I found. It kind of gives you an idea of what this is going to look like. The right side's your basic, like a client-side rendering. You'll have your app. Well, it'll be called app.module TS, and regular one, and this side is the server side, obviously. So, and then basically there's these three main files that I kind of want to focus on. So let me go over to my code. So like I said, it's a Angular CLI app that is generated. So you're gonna have your app.module TS, and then there'll be two files that live like side by side with that. It's the Angular browser and the Angular server module. So the browser module, if you'll see, it does import the app module that I showed you first. The server module does as well. And then this line's really the key line. So browser module with server transition, it's just letting Angular know that you're going to use server-side rendering. And the app ID, just give it any string, basically, as long as it matches what you have in the server module. So again, this is the exact same file. Obviously different name, and then we import the server module. So that's pretty much it for as the modules go. There's not a whole lot else going on. You're gonna have a server file. This is basically uses Express and Node. So obviously import Express, create the server, and then the key line here. Well, the import here is the ng Express engine. It's something from the Angular team, the Angular Universal team. So not a whole lot to it. It's very basic. Copied from their setup on GitHub. So you create the engine and bootstrap your server app module, set the view engine as HTML, and that's pretty much it. As far as those files go, you'll have your regular main file. You'll have a main server TS that basically just exports your server module, and then there'll be a little bit config as well. You'll have just make sure your Angular compile option. You gotta set your entry modules for the browser, your browser app module, your server app module, and then let the Angular CLI know about it. So that's really it. I mean, there's a lot more to it. Obviously, if you have a bigger app, but for me, that pretty much covered what I needed to learn. It's not nearly as scary as I thought going into it, which is kind of the point of my talk I wanted to get out of this. Angular Universal sometimes server-side rendering seems more complicated, but it's a pretty low bar to entry, especially for smaller apps. And then I just kind of want to show you the small app I did. So it's a different app. Just there's two components, the home and about page. The main thing is you have a title and you have some meta, and that's really what you want the search engines to be calling for. So the home will have some title, some keywords. About's the same, different title, different keywords. Let's go over to homepage, view the source, and we have my title, and we have my meta. And the search engines are able to crawl that and index it. And the same thing with the about page. View source. So yeah, there's not too much to it. I didn't want to go too in depth. Here's some cool links that I use some walkthroughs, some things on server-side rendering pitfalls. Again, that link to the Express engine for your server-side. So yeah, that's pretty much it for me. Did anybody have any questions or anything?
Among the links you listed, which is the best place to start?
For me, I like this Mal-coded one. I think he has some very good, just some fundamentals, and then he has the link as well on server rendering pitfalls. Because yeah, I followed a couple of these tutorials in the Medium article. Put together, it all kind of made sense, but I feel like his step-by-step the best. I understood the individual parts the best. And then there's the the seed app you can kind of look at to compare with those. So.
Good question, but I don't want it to go.
Yeah.
You just briefly walk through the flow. So the user hits a URL in the browser, and then the Express route obviously runs, and then didn't follow exactly how the files are communicating, but only if it's like a 30-second kind of point to show.
I probably couldn't explain it either. But yeah, I mean, basically it grabs the static, the pre-rendered HTML from the server, and then it'll be swapped out once the app is fully loaded. But yeah.
So basically what Universal does there is so Express has its own router in between it, and then your Angular app has a router as well. Mm-hmm. So the Express engine sort of will pre-render just the bare bones HTML page, so you'll get your meta and your images and all of that kind of stuff. So when something crawls that, they're getting a pre-rendered cached version of your application, and then when you actually go to it, that's when it actually does all the server communication to if you need to go get data or anything like that, and then Angular kind of takes over from there.
Okay. Cool. Yeah, if that's it, I'll.
And Rizzo, are you ready?
Yes, I am. Can you give me presenter rights? I don't think I have presenter rights.
You should be able to just share your video.
Oh wait, yes I do. Never mind. All right, so we heard a couple of really good talks about Angular-related applications, and we're going to be switching gears a little bit here with Kafka and WebSockets. So my goal with this project really was to get the benefits of Kafka over to the front end and find a way for Angular, any application using Angular or similar front-end frameworks to get the benefits of Kafka. Yeah, so before I get started with the details, I work as a software architect at Bulhan, and this project really, I think it came from, we're actually doing a lot of work with Kafka, or Kafka, as you are supposed to pronounce it, at Bulhan to introduce it to some applications and do some really cool things with it. And I know I can't see anyone, but can we have a quick show of hands, or maybe Josh can relay over the number of people who actually have heard of Kafka or know of Kafka? Okay, cool. That's fine. I'll be going over what Kafka and WebSockets are. I'm assuming people are a lot more familiar with WebSockets. So let's start with that. So as you probably already know, WebSockets is it's a way for server and client service to communicate with each other. It sets up a two-way communication channel. It's great for things like notification, quick interactions, any process that is basically taking forever on the server side. You don't really have to wait for a response to come back. You could just wait for communication on your WebSocket if you have that set up. So, I mean, there are some really big pros for WebSockets. I'm not going to get into it too much, but I think one big thing about WebSockets is that there's no real way to store the communication that actually happens within a WebSocket. So if you have the server trying to communicate with a client, someone's actually closed their browser, then that message is really not going to anybody. I mean, they're not going to be able to communicate to the client once the socket connection is done. So, so that I think is one really good place where Kafka comes in. So Kafka is a pub/sub technology. You may have heard of similar technologies like RabbitMQ, HornetQ, and some others. So Kafka is similar to that. It is a message queue. You basically send messages to something called a topic. So and then someone subscribes to the same topic, and then they get the same message. The big thing about Kafka is it stores the data, stores the messages, and it doesn't get lost into the oblivion when your server goes down, and then you suddenly don't have any of the messages that were sent to a particular topic. So that's one big pro of Kafka. But so what I mean, a little bit more about that is it's distributed, fault tolerant, yada yada yada, and yeah, we don't really get into the nitty-gritty of Kafka, but I think that might have given you be a good enough explanation. At this point, I'd like to ask if anyone has any questions or would like me to elaborate on what Kafka does or anything about WebSockets, anything that we've discussed so far. No?
No questions here.
Cool. All right. Perfect. So so then I'm going to talk a little bit about my experimental project. And I think the key word is experimental, because this is definitely not a system that I would recommend setting up in production. And I will talk about a little bit of why that is. And really, the goal of this project was to see how can we really make use of this persistent message queue to better send notifications from the client, from say one client to another client. Like if we have two people chatting with each other and we have this WebSocket connection, if one person goes away, then we still want to get the messages over to them. So how do we do that? That's where Kafka comes in. So I have this Kafka cluster set up, and we have this Express Socket.io server also set up. So Socket.io is an implementation on top of WebSockets. It uses WebSockets and other related protocols to let you communicate to the client from the server and so on. So so using this, so let's say a client sends a message. What we do is we store that message in a specific topic for client 2. Oops. Yeah, we store that message from client 1 in a specific topic for client 2, so that that message goes to client 2. And then we have a subscription to that particular client's topic. And then if there is an open WebSocket connection, we send that message back to client 2 so that client 2 can see it. So, all right. So I'm going to go to the code a little bit, but before that, maybe in my make a little more sense if I show you a demo, and then maybe we can go to the code. Oh, demo is right here. All right, so I have two vanilla client apps set up. So by refreshing the page, I'm reestablishing my WebSocket connection in case it died. All right, hey from client one. All right, if I go here and if everything worked, then yeah, it did. So I see hey from client one over here, and then hey from client two. And you see that client one received this message from client two. So let's close client one and then just say hey again, client two. I'm gonna zoom in. Let's see. Is it better? Are you still there? So not hearing back from client one. And then I'm going to open this client one browser. And then I see that client two has sent me a couple of messages, and I'm just receiving those messages because I just got back to my computer or whatever. So that is a little bit what the demo is. So hope that makes more sense. Any questions so far?
Yeah, we have one question in the back.
Yep.
I just have a basic question. Like you mentioned Kafka as a messaging queue and topics. Mm-hmm. So how Kafka is better than other technologies such as MQ series or Apache MQ? Is there any added advantage of using Kafka over those?
So I think it kind of very much depends on what kind of use cases you're trying to use it for. If there is a large amount of streaming data that's coming into your system that you need Kafka for, one thing, so a little bit history about Kafka. Kafka is a technology that LinkedIn set up for tracking their page activities and some other things. So anytime someone clicks or any login, that it just goes directly to Kafka, and that you can imagine the volume of that kind of transactions. So so that's one big advantage, is that it's scalable and fault tolerant to handle large volume of messages. And the other big thing is that it is persistent, because usually I'm not sure about Apache MQ, but I know that RabbitMQ and HornetQ don't actually store the data. So if the server goes down, then you lose all the messages. So the thing about Kafka is that since it stores all the messages in memory, it, even when your consumer comes back, and then you can actually pick up where you left off in terms of the last message you read, and then resume from that point. So reading the messages in order and things like that, those are some benefits of Kafka. And I feel that is one reason why notifications is probably a very good use case for Kafka. Like notifications in the sense of Facebook notifications, when you have a notification drop down, there are some notifications that you've read and some you haven't. How do you persist that information, or how do you transmit that information? I mean, it's not the same exact use case, but that's something what I'm exploring, is like, how can you make use of Kafka and WebSockets to provide a good notification system for Angular applications primarily.
Okay. Second question regarding WebSockets. So here, client one is sending message to the queue, and client two is subscribed to that queue and getting that message. So where WebSocket is coming into the picture? Is it between communication between queue and client one? And how you implemented WebSocket? Did you use some kind of APIs? Or
So WebSockets is a way to for a client to communicate with the server, and maybe this is a segue for me to go to the code as well and find it. So I have two clients here. I have client 1 and client 2, which are exactly the same. So the only difference is that it has this kind of ID that it uses to register with the WebSocket. So it uses the WebSocket here. Maybe I can increase the font size.
Hey, Martha, can you zoom in, please?
Yeah. Is this better? More, maybe. Is this better?
Yes, thank you.
Cool. Yeah, so both the clients have the exact same code. They're using the exact same JavaScript, and it's very basic jQuery to update the form anytime there's a new message. So the important part here is that it uses Socket.io to create a connection, and then it basically listens for messages. And anytime there is a new message, then this callback function will be executed, and it appends data to the DOM and so on. So this socket connection is what helps the client side to communicate with the server side. And on the server side, we have a Node Express server running. So let me quickly go to here. So here I'm using Socket.io to set up socket available at port 3000, and then it's very basic in the sense that it listens for register, and then it stores that information, and as soon as it gets a new connection, it creates a Kafka consumer. And this happens on the server side because we don't want to expose Kafka to the client side, and that's a whole different thing. But it establishes connection with Kafka, and then it gets a Kafka consumer, and then it again listens for messages on that particular consumer. So anytime there's a message, then again this callback function is executed. So once that happens, once there is a new message for the notification stream that it's listening for, it takes that message and then puts it back into the socket and sends it back to the client. So that's kind of what happens. It's pretty simple in the sense that all we're doing is taking a message, putting it into Kafka, taking it out of Kafka, and putting it back into the socket. It's just that it's going from one queue to another, and that's really it. Does this answer your question?
yes. So if client gets offline, and message accumulated on the queue, so will those messages be delivered in order they received on the queue, or will those be like delivered asynchronously?
Yeah, good question. So let's see. Establish these connections again, and then let's see. Hi, right, and then 2 goes offline, and then okay, 2 isn't there, but 2 comes back online, and then 2 sees all these messages in the same order that 1 sent them in.
Okay, thank you.
Yeah. Yeah, does anyone have any other questions or anything about why I'm talking about this in an Angular meetup? No. Okay.
But there are socket.io wrappers in Angular too, so you can easily take the easy HTML page that Amrita had there and make it an Angular application and have like a rich chat program or sort of anything.
Yeah, so the code is out on GitHub if anyone wants to take a look.
We have
So-
one question.
Yeah.
Walking around.
Okay. Hello. I think you mentioned that the message that you submit has 3 properties, like a key value and timestamp.
Mhm.
Is that just for this example, like based on how you set up your Kafka instance, or is that a standard?
So yeah, so that's a good question. So that is actually a Kafka thing. So when so here when I set up a Kafka producer, as you call it, where is my producer setup? Right. I have a very basic setup. So I could choose to, yeah, I could choose to include a key for every message. You know, the key really is to help with kind of load balancing. But if you have like specific information that you would like to send to a specific part of the Kafka cluster, then you can use that key to differentiate between different messages. The timestamp really is defaulted to the current time, but I could potentially, I think it's over here that I would add some kind of, I forget what the syntax is, but you could add a timestamp with every message that you're sending to Kafka too. But by default, the key is at random. Actually, I'll show you this. So this is a tool called Kafka. And it's just a tool that we use to view what's in a topic. So this was the topic that I used for client 2. So all these messages would go to client 2. So here, if you see, there is a key associated with it, but it's null because I didn't really specify any key. And there's also the concept of partitions. Over here, we have 3 partitions, and really the key is kind of associated with a partition. So if you want the message to go to partition 2 as opposed to partition 0, then you can specify a key.
And so the root of my question was, can you use it to send more complex objects besides just messages, or is it mainly for chat?
Oh, absolutely. So here the communication is via JSON. So I have a JSON, which is one key that says message. Okay. So you could do whatever you want with it. You can add multiple keys, and you could make a JSON subarray and sort of, yeah.
I was thinking that too. I was trying to think of another real
So there was a question. So do we use Kafka here at Bullhorn, and sort of what are like the more like real world examples that you can think of for it?
Yeah. So yes, we do use Kafka at Bullhorn. We're just starting to use it. I mean, the primary thing that we're using it for at Bullhorn is when you make updates to data. If you make an update to a specific type of data, then we send what is called a data event to Kafka so that you can subscribe to updates to a certain kind of data. So that is one real world use case. And another use case that some people use it for is when you have activity tracking. And I think that is the more popular use case, when you track users' clicks, and with every click you emit a message to Kafka. And another thing that people do is often couple Kafka with another stream processor so that you can do calculations on the fly when you have a stream of data coming in. So that kind of setup is what people use it for.
Does anyone have any other questions? Good questions. Well, yeah. So we have one last talk. Thank you, Amrita.
Thanks.
We have one last talk, and it's Michael on Ionic.
Are we not doing Dylan's?
No, Dylan had to step out today, so just straight to you.
Am I registering audio over there?
Yes.
And I'm not sharing my screen, am I?
Yeah, your audio is coming in good. Here we go.
Hi, everyone. Thank you for sticking around until the end. I'll try not to keep this too long. Thank you also to Bullhorn for hosting us, providing the facility, pizza, beverages, etc. I enjoyed each of those presentations, so hopefully this one's good as well. The purpose of this discussion is basically for the non-technical people in the audience who haven't worked with Ionic before, just basically to show how easy it was for someone like myself who didn't have a background in programming to learn enough of the languages involved to create an MVP, minimum viable product that we were able to sell to customers and eventually deploy in the field. And for those of you who are more technically advanced, hopefully the sort of fuzzy stuff about the mission that we're doing is interesting enough for you to sort of keep you engaged and more. So I'm going to talk a little bit about what prompted me to start my nonprofit tech startup, Johigo. I'm going to talk a little bit about the problem we're trying to solve and what we're doing that's unique. And then I'll talk a little bit about the process of building out the app, really not knowing what the heck I was doing for most of it. So I actually studied civil and environmental engineering during undergrad and grad school. And although I took a couple of programming classes in undergrad, the languages were C and MATLAB, so not really particularly relevant to mobile application development. And although I had played around a little bit with building websites in high school, I didn't really do anything with that at all in undergrad or afterwards. But in any event, once I finished grad school, I moved to Seattle to work as environmental consultants. And I didn't know anybody in the community at the time. So after church one Sunday, I decided to stick around for free coffee and donuts, thinking maybe I'll make a friend. Worst case, I get free stuff. I was sitting at one of the many reasons why I'm here. I was sitting in the back of the room getting the lay of the land when I saw an elderly parishioner approach a very haggard stranger who had clearly been living on the street for a long time. The elderly gentleman patiently inquired about the stranger's needs, and then by memory, directed him to 3 separate locations where he'd get a hot shower, a warm meal, and help with his immigration trouble. I was blown away by his level of in-depth community knowledge and how that knowledge within a matter of a few minutes could potentially radically transform someone's life for the better. And the more I reflected on that story, the more I got excited by the possibility of what if not just a select few, but if every single person with a smartphone possessed this information at their fingertips. I'm really excited. But the more I looked into it, the more I learned that it's not just opportunistic do-gooders like me who lack such information, but often the people that we pay to connect people with resources. So in order to illustrate this, I'm going to provide one example. So sometimes when people go to the emergency room for an acute medical condition like drug overdose, it's actually symptomatic of a chronic problem like addiction or pain or depression or maybe job loss that cause one of those other three things. There are medical social workers whose entire job in emergency rooms is to direct people towards services that address those chronic conditions. I interviewed one of those here in St. Louis, and she said that of any given 12-hour shift, she spends about 2 hours on average Googling resources for her clients. And that her story isn't uncommon. There are social workers, police officers, nurses, and other people who day in, day out, their job is to connect people with resources. And the 3 main ways they connect people with resources are word of mouth referrals, which are anecdotal. paper directories, which are out of date the moment they're printed, and then hours upon hours of unstructured utilization of free search engines, which is inefficient and ineffective, particularly if the websites you're directed to are out of date. Not a lot of nonprofits keep their websites wholly up to date. I'm not the first person to observe this problem, and Johigo isn't the first organization to be created to try and solve it. A variety of nonprofit and for-profit companies have either on a local or national level aggregated information and then delivered it in a variety of formats. Mercy Ministries, for example, creates a paper directory that they give out for free. Purple Binder created a paywalled web application that people can get access to. 211, for example, which is basically a disaggregated network of United Way's, cities, counties, archdioceses, and other entities, basically has a hotline that either people that need services can call into or the practitioners connecting people with services. One thing that unites all of these is that every single one of them has struggled to keep their information up to date. Really broadly speaking, the nonprofits lack the technical expertise in-house to do so in an efficient fashion. And the for-profit entities are competing against quote unquote free competitors, word-of-mouth recommendations, free printed paper directories, and Googling. Even though those things aren't free because they take time, those sorts of things aren't being captured for most agencies where social service professionals work. Notably, another thing that's kind of interesting about these entities is that very few of them have leveraged smartphone applications to deliver their information. And fewer still prioritize them or keep them very up to date. So I thought that, and although we're not going to cover the topic today, I felt like we could maintain our information in a more efficient fashion. And I also felt like smartphone applications would be a good entry into this ecosystem and potentially sufficiently unique to justify the whole endeavor. So eventually, once I was convinced of that, I started doing some more research on the technical side of things. I, again, and only a little bit and hadn't touched HTML for a long time. So I started with the basics. What are the most common operating systems for smartphone applications? What languages are required to write for those operating systems? And what are the fastest ways to learn them? And then one of the things I learned, as you're all probably well aware of, is that there are some code bases you can write, like Cordova, where it can compile into different languages for multiple operating systems at once. That seemed really easy / efficient. And because it was based on HTML, it seemed like a good place for me to go. So I went through every single W3 Schools tutorial that I could, signed up for a 6-course sequence through Coursera in conjunction with the University of Hong Kong Science Technology, and then learned a bunch of JavaScript-based front-end and back-end platform technologies to kind of slowly turn my way forward. So ultimately, we ended up with a stack that looks something like that. Front end on the left, pretty basic languages. I avoided the later versions of Angular and Ionic because I didn't want to learn TypeScript, although it ultimately probably has some advantages. On the back end, Node.js, MongoDB on a Roku. That's sort of what we used to generate our minimum viable product. So what do we build? Again, so fundamentally, the problem we're trying to solve is to make it really easy to find resources. Through the app, there's 2 main ways to do it. You can type in a keyword, and we search our MongoDB database, and you're provided a list of organizations offering that service. Alternatively, you can navigate our hierarchy of service categories. So maybe under healthcare, there's going to be emergency medical care or specialist care, things like that. Eventually, we provide a list of service providers. You can sort alphabetically or by proximity, or you can see them all on a map. Found a provider that you find interesting. Each one has a profile page. You can get directions to them, give them a call. If a website, go there for more information, and then see a list of all the service categories that they offer. Because this is all HTML, CSS, JavaScript-based, it was really easy to integrate with existing web APIs like Google Maps directions or anything to do with sort of geolocation or just displaying on an embedded Google Maps page. Also on a provider's page, you can send feedback if something's out of date or incomplete. You can send us notifications and we get those and we address them typically within about 14 hours. Or you can add particular provider to your list of favorites for quick reference. And then on the back end, we can start doing analysis on what types of organizations are favorited by what types of people, and whether there's any sort of clustering that occurs. Maybe half the social workers in a community tend to favor one type of medical provider, and that's but the other half does something else. That might be something that would be illuminating for public health agencies, et cetera. So if you haven't done any development on Ionic, for me at least, it was really kind of enjoyable and surprisingly user-friendly, I guess, for lack of a better word. I would develop my code base, and with one command on the command line interface, you can basically simulate an iOS application, an iOS device, Android device within the comfort of your browser, Ionic serve -lab from the sort of project folder, and you can see whether it works. Once you think it's sort of stable enough or far enough along, you can run it locally on your device. You basically, it's a little bit different for iOS and Android, but you plug in your phone, you type in a couple of commands to the command line, and then it's running locally. And then you can kind of work out the bugs there, et cetera. So I was kind of going through this process, interviewing people at every step of the way, getting their feedback. And then meanwhile, the business development I've been doing started to bear fruit. One of my allies at the Mission Center was working with some folks from Health Literacy Media, basically to organize social service agencies and medical agencies and rural communities to help improve health outcomes in those communities. In Hannibal, Missouri, one of the things they identified was lack of access to information, and they were going to pay some folks to create a paper-based directory. And my ally introduced them to me, and I said, we can do a lot better for the same amount of money with a smartphone application. So we convinced them to sort of buy the app, even though it's free for download. That sounds evil. We sold them on the vision of what our app could do, and that it would be free for everyone. And in fact, that was part of the vision. And then that we would train their professionals on how to use it, because we make all of their partner agencies more efficient and effective. Publishing to the app to Google Play was pretty easy. Publishing to the App Store was really annoying. If you haven't done that and you're planning on doing so, I would give yourself twice as much time as you think you need. You have to get like DNS numbers and all these hoops you have to jump through, and it's pretty dreadful. Google Play, to be a good developer license, it's like I think like $99. The App Store, it's like 300, something like that. But just know it's gonna be a lot, and they're gonna be more persnickety about like the content you put in the descriptors too, or in the screenshots and things like that. And sometimes what they're persnickety about is also very opaque. So just FYI, it's gonna be terrible. In any event, once we did a soft launch with the coalition that we were working with. We had an in-person training session. Did some troubleshooting. They recommended some additional features. We iterated that a couple of times. And eventually, once we got it stable enough, we had a big public launch. And like local media came, and it's now being used in about 6 counties in Northeast Missouri, and we're expanding to others. So obviously, I covered a lot of ground and barely touched the surface on some of the technical things, but maybe that's good because we got a lot of really, at least what seemed to me really awesome technical content beforehand. But some of the things I didn't include, but I think are relevant from that moment that I had that sort of experience that inspired Johigo. The vision for what we were trying to do has changed pretty dramatically a couple of times. Additionally, I didn't really get much into the weeds about how we maintain our data and how the app is sort of a key feature of that. And we really haven't talked about a whole lot of the milestones we achieved in the way, including tying for first in the Social Enterprise Innovation Competition at WashU a couple of months ago. But fundamentally, my motivation for this was twofold. Number one, if you haven't worked with Ionic before and have an app idea, for somebody who didn't have any programming experience beforehand, within several months, I was able to take a bunch of classes and develop a minimum viable product and get someone to buy it, and then actually sort of deploy it as well. And so if I can do it without having any coding experience basically beforehand, I think that almost certainly all of you can too. And then secondarily, for whether or not you've worked with Ionic, or if you are a backend developer primarily, or a front-end developer, or you consider yourself more of a data scientist, another reason why I want to give this presentation is that we are looking to interview people matching those 3 descriptions. So if the sort of problem set that we're working on is something that interests you, and you have skills you want to apply to it, then shoot me an email afterwards. So thank you for your attention.
Awesome. Well, thank you.
Yeah.
What's the name? Johigo.
Okay, so the question was, what does Johigo mean? So it's an Iroquois. It's based on an Iroquois Seneca word that translates to "what we live on," and it's used in ceremonial speeches. But really, it's an allegory for companion planting. The basic idea being that things grow better together than they do separately. As a nonprofit tech startup, we can use our expertise in data analytics, mobile tech, to make people who have expertise in sort of psychology and medicine, et cetera, more efficient at what they do. So our powers combined are better than if we were not working together. So I thought Johigo sort of captured the spirit of it. And our version of it is easier to spell than the actual translation, which has a bunch of extra H's and umlauts and backwards accent marks. And this is easy to trademark too. So that was part of the reason for the name.
Excellent.
Yeah. Are we okay time? Do we have time for more questions?
Oh, yeah.
Okay. Yeah, sorry, go ahead.
Well, whenever the presentation
Thanks.
and the solution, it's too. It's cool you're going out of your way to fix a problem. Well, if you're doing it better. So
Thanks.
that's cool. My question though too was, how do you capture all this data? How do you capture all this information? Like, where do you get these resources? Is that all done by hand? Is it
So the question was, how do we basically capture information that populates the directory in the app? So it's a multi-step process. We basically aggregate various public data sets that are released by the government, various government agencies. So like IRS, Missouri Attorney General, Illinois Treasurer, et cetera, have all publicized some type of information about some types of providers. We combine as many of those as we can, and that any data discrepancies or gaps that occur, we address through crowdsourcing. So within this first iteration in Hannibal, we had a volunteer pool of about 12 people, and we created like 226 micro tasks for them to complete, call this provider and ask these questions. It was really kind of Frankenstein together with like Google Forms and things, and they completed those calls, and once those were addressed, the results of their calls we then added to our sort of master data set, and then that became the sort of MongoDB document collection that the app calls. Subsequently, once people say something is out of date or incomplete, et cetera, and they fill out the form that says that, it goes to a sort of REST API endpoint that we define that creates an email that emails me that I then independently follow up on. In the future, we want to integrate so that the whole thing is then pushed to our sort of community of volunteers who then are able to see how many like agencies' information they verified. They can compare it against their friends. They can share it on social media. We can keep track of service hours. So if you're a high schooler or you're a parolee or for whatever reason you have to do sort of community service, we can like then sort of document that too and gamify it. So right now, the initial collection is pretty automated. The maintenance is manual. So in the future, we want to make the maintenance automated as well, pretty much. Thanks.
I guess while you're explaining too, I guess once you have more of a user base too, you could probably do anything like if there's something that's really missing, like a place that's really missing, a resource that's really missing.
Yeah.
Maybe there's a form that they could put to suggest adding that as a resource.
Yeah.
And then you could also do something too where it's like as they're typing the location of the name or address, you guys are constantly hitting your API, checking to see if there's any new suggestions that also kind of match that. And then maybe you can do something like, this location has like 5 suggestions created. It's like a prioritizing system, you know?
Right. So, yeah, so the suggestion was to add, basically create a form for people to add providers that are missing, and then also to do sort of smart recommendations or smart searches based on what people's demand is. So just a couple things that might be worth mentioning. One of the things that we've done so far is we've had users that say, hey, we really like this app. We have this like 10-page stack of papers for referrals that we don't want to use anymore because of your app. Would you be willing to add it? And so they just like faxed us their resource thing and like, okay, sure, give it to the interns and they'll transcribe it. And then we sort of like go through the data validation process, whatever. And that's been a really nice way, not only to increase the size of our directory, but also to like create more loyal users because then they can see the things that weren't there more sort of became that way. In terms of like sort of smart recommendations, so every time somebody does a search, we confidentially and anonymously record the time, location, and nature of that search. So you can see what's being asked for where, compare that to where those services are being offered, and then maybe in neighborhoods with a high demand for homelessness services, for their homeless shelters, that's something that policymakers would be interested in. Or you could overlay that with like legislative districts, and you could see who's voted against funding for a certain thing and say like, hey, you're in the 99th percentile of legislative districts for that cause, like what gives kind of thing. So I think what we are hinting at is that there's like a ton of opportunities for like kind of smart searching that's like leaps and bounds beyond like flipping to page 12 for a thing that might not even be there anymore. So any other questions? Okay.
When you developed it, what did you gain out of using Cordova in the mix?
I rarely used it directly much. I mostly, so this sort of, I think, is going to display how I managed to do this without knowing what the hell I was doing. But for me, like the line between Cordova and Ionic was always very blurry. And it felt like I was doing things with Ionic and like packages that people put together that they themselves probably did that accomplished Cordova tasks. But for me, I couldn't tell the difference. I just saw that like, oh, I need my Ionic to do a thing. And somebody created a package to do the thing. And hey, look, it did the thing. Next problem. And like, honest to God, like it was like blindly the blind. So, which is why I need real developers. So, any other questions? Okay.
That's awesome. I just wanted to give a quick shout out to all of our speakers tonight. Thank them for their time. All the talks were pretty awesome. Had a lot of information. So I'm just going to go ahead and stop the broadcast.